Hi, my name is Hamid Ould-Brahim. I'm product manager at Nokia. I'm going to show you here an interesting demo in the space of controlling network, doing traffic engineering in the network using intelligent type mechanism in order to achieve a better efficiency and better operating IP networks. So in this demo, I will show you how insight-driven network automation. Insight means understanding the traffic going into the network, understanding what type of traffic, for example, Netflix traffic, YouTube traffic, Twitter type traffic, and achieving automation and optimization for OTT carriers, cloud networks, web scale and SDN traffic using Nokia, using two products that cooperate to realize this use case, which are Nokia carrier SDN product represented through Network Services Platform, which we call the NSP, and the Deepfield platform, which is a company we have just acquired that allows us to do traffic analytics and analysis. So we're going to use both in order to achieve this use case. So, okay, so I'll start by describing what this use case is all about. There are two steps in this use case, or two options. The first option I'm going to show is what we're calling optimization at the peering only. Here you have a network. That network is connected to different service providers, for example. And they are peering. This network is peering at the BGP level between different service providers. What happens is that when traffic is running high, these peering links becomes congested. So we experience congestion. Congestion implies delays in the network, delays in the quality of user experience. Let's say someone is watching Netflix, then he's going to see degradation of the quality of experience of its feed. And then in this case, we want to have a mechanism that detects automatically this congestion in the network and then act and then try to resolve it by rerouting certain type of traffic to alternate peers that have available bandwidth. So this is the context of option one. So let me describe it in terms of network reference for the demo. So in this case, as I mentioned, you have a feed of traffic into the network, into a service provider network coming from, let's say cloud providers, content delivery networks, ISP, web, OTT type traffic going to inside the network here, let's say 32, 31 routers, and going to the peering node, in this case 35 or 33. And 35 node is peering to a different type of service provider and having what we're calling EBGP type peering. And on these links, we are experiencing congestion. So to resolve this congestion, we're going to use an architecture, and carrier SDN architecture combined with analytics, which is in this case Deepfield. So Deepfield will try to build visibility of traffic on the peering links. Visibility implies they can tell us what this traffic belongs to which source, let's say Netflix source or YouTube source. And they can give us even what are the routes associated with this service, the IP routes, the IP addresses associated with this service. And then they can tell us what's the real-time bandwidth that's going through that particular link. So having these three information, they feed NSP with this key, what we're calling telemetry type information, and NSP uses this data in order to make routing decisions on the network and start programming the network to say, you know, now given this congestion, given Netflix traffic on this link 112, for example, that is showing orange, for which showing that the traffic is going high, redirect traffic to an alternate peer, in this case, 39. So we want Netflix traffic, for example, to move from node 35 to 39. Option 2 is the same problem. You have congestion on the peering, but the action happens anywhere in the network, which is more proactive, which means that if if a peering link is congested due to Netflix traffic, we want then to go to somewhere in the network where Netflix traffic is entering the network and start redirecting from that edge of the network instead of going to the node that is experiencing the problem. And that the value here is either using traffic engineering techniques to allocate tunnels that meets Netflix requirement, bandwidth requirement, for example. And even further, we can go even to an alternate peer to redirect traffic, not necessarily the same peer experiencing the congestion. So in terms of option 2, so the mechanism will say the problem is happening at the node 35. We're going to go to node 32. We're going to establish a segment routing LSP to node 35 having certain traffic characteristics, bandwidth characteristics, or engineering characteristics. And from there, we're going to redirect traffic to an alternate peer, in this case, 39. So I'm going to show you both options in this demo. So in this case, I'm going to the network services platform. We have a number of applications already supported on that platform. We go to the traffic steering type application. In this case, I clicked on the right applications. So when we enter that application, we have all the routers we are interested in. So which means that NSP is peering with these routers to control these routers from a controller side. So in this case, I have router 32, router 33, router 35. So we're interested option 1 at congestion at router 35. So to start doing the work, so I'm going to the settings of that NSP. So the first step is to discover what type, now I found congestion, what type of traffic is on this link between 32 and 35. Then in this case, the way we're doing it is to run what we're calling an inside optimization site. A site can be, let's say, Netflix, YouTube, Twitter, Facebook, Amazon, and so on. The site is provided through our connectivity and our integration with Deepfield. So when I click on it, I have two options. Either I add the site manually. I can say Netflix name, and this is the server, this is the IP address related to Netflix or set of servers. This is manual. This forces the service provider to track manually what servers are associated to what type of feed, like Netflix and so on. But with Deepfield acquisition, we can now do it automatically. So Deepfield discover automatically what type of traffic on that link and feed the NSP with the site name and the addresses. So if I click on discover new site, it means go to Deepfield, NSP will request Deepfield system tell me what traffic is on that particular peering link. So in this case, I click on it, and you will see the site appearing. So in this case, on this link, I have Apple traffic, I have Netflix traffic, Sky traffic, Verizon, or YouTube as examples. And in addition to the site name, the Deepfield provides you as well what are the subnets or the routes associated with that particular traffic. So in this case, for example, Netflix traffic, I have 5 subnets, which means 5 routes, 5 BGP routes are associated with that Netflix traffic. Having that information is enough to start doing automation and ability to resolve congestion in an intelligent way than what we are doing today. Today, the service provider, they don't know what type of traffic. They can't say this service is Netflix or this traffic is Google and so on. So when there's congestion, they blindly move some traffic from one peer to another. So with this solution, we're providing them a way to do much targeted type selection of what traffic to move. So in this case, I will show you here, I will go back to the routers and I will show you how we steer traffic to alternate peer. So the first thing, I'm going to check the port. How much utilization on the port? Do I have a lot of traffic on the default port? So if you look here, you will find that 63% of traffic is going through the default peer, which is orange, which means it's high. 63% is reaching a higher utilization, and it can go even 80%. And when there is congestion, the consequences are really severe. Maybe control packet gets dropped, and routing protocols may reset. So the implications is not just on the end user, but as well on the networks where this traffic is being delivered. So in this case, I have like here on a default port, I have 63%. I have the ability as well to see what's the history, how traffic did in that particular port. So I can go to the last hour, or I can go every 10 seconds and I can show the traffic going. So as you can see here, I activated real-time utilization, which means every 10 seconds, we're tracking bandwidth utilization, link utilization on that particular peering point. So in this case, I'm hovering around 70% utilization, which is quite high. So let me now, having 70%, having that information, now we go to Deepfield and say, okay, tell me about the nature of traffic. 70% of bandwidth utilization, who is using this 70% utilization? So I go into the insight optimization option, and then in this case, I'm presented with the site names, the subnets associated with the site names, and as well the actual bandwidth, the real-time bandwidth. So in this case, I will say, in this case, we discover that Netflix.com, that has 5 subnets, has a bandwidth of 20 meg. And I can even click on them, and I can see for each Netflix here, Netflix.com, for each server of Netflix, I can know what exact bandwidth they are using on that particular link. And I can even go even further. I can tell what interface in the router for Netflix for that particular address. So in this case, 8 meg for router 35 to 38, which is the default route. So what I'm trying to do now, having this information, now the controller can act on the network to make the traffic less on the default peer and move them to an alternate peer, move only Netflix traffic. So what I'm going to do here, I'm going to, we have an option here that says steer VIP customer, which means steer the site itself. So if I click on it, I will be presented with the Netflix.com traffic, all the subnets associated with Netflix, and then I can say continue. And then I select where I want now this traffic to go. Now, because 35 to 38 is congested, I want to move them from 35 to 39. So I select the next hop to be 39. And I can even redirect to an LSP. That's in the option 2 I will show you later on. So if I click continue, I verify the policy. It says five subnets will be steered. Steering here implies injecting in the router the flow rules that will redirect Netflix traffic. And it's done in a transaction way. That means each subnet here, NSP will construct an open flow rules or steering rules and inject it inside the router. And transaction means all of them get steered or none of them get steered. So when I do finish, we should see the steering happening. So in this case, it shows here active, which means all Netflix traffic has been moved to an alternate peer. So if I go to the port again, and this one is every minute get populated, I go to the alternate peer. Right now is 0, there is no traffic. So if I track it per 10 seconds, I should see on alternate peer, traffic is going up now. That's the 39 nodes. So if I see each 10 seconds, it's going to appear and showing now it's no longer 0, it's going high on this particular link. So as you can see here, it appeared here that we have like 20% on 39. That means it's not 0 anymore. That means traffic, all this is Netflix traffic going to 39. If I can do the same thing on the default port, as you can see, now it dropped 44% because we removed 20% of traffic, which means now we reduced congestion on the default peering. So this is an example how you can steer traffic to alternate peer. And all this, in fact, we support them either through GUIs, when the operator wants to operate the solution, the use case, or through APIs, when the service provider or the customer wants to build its own application and use API to act on the network. We offer both options, in fact. So in this case, if I want to steer even more, I can go and steer YouTube traffic. Then I can say same thing. I can say continue. I select the same alternate peer, which is 39 in this case, and I finish, and all YouTube traffic is steered. So if I go even on the alternate peer, I should see now that I have more traffic on the alternate peer. So if I track it, and it's going up, as you can see here. So I will track it each 10 seconds. Before it was 20. Now, because I steered YouTube traffic, it's 50%. And if I go to the default path, then I should see even less traffic on the default peering, that the ones that experienced congestion. So every 10 seconds, and it's going down now. So we're trying to resolve congestion in this case, and it's working by doing the steering capabilities. And here you will see it a bit less. So before it was 70%, now it is 30%. So this is phase one of the options. And we offer within phase 1 and 2 the ability for the customer to go to Deepfield directly from NSP. And then they can understand the traffic, generate reports according to the use case that we had before. So here I'm going to Deepfield, and I will show you, Deepfield will provide you his Netflix traffic, how much traffic on this particular routes, and I can display, I can add whatever report I want to generate. And here, for example, I have 51% of traffic for this address of Netflix. It was moved and so on. I can even produce, more interesting information here about the use case. This is coming directly from Deepfield. So option 2, the action is happening at the edges of the network, which means the steering is happening across a tunnel that we have to create on demand automatically once we detect the congestion is happening on the peering. And in this case, we added the capability to say, create an LSP. Create an LSP will create a segment routing LSP from edge 32 to the peering experiencing the problem, which is 35. So I'll give it a name, tunnel, or let's call it Netflix tunnel that leads from 32 to 35. So I will select here what's the controller, the PCC node for it, and the source address will be 32. The destination address will be 35. The profile ID is the characteristics of this tunnel, what type of bandwidth, what the optimization is. In this case, we are using TE matrix optimization, and it has profile ID of 100. And if I click, and group ID, I add a 0 for default. If I click save, what happens inside the network is a tunnel is automatically, dynamically created. And then in this case, when I say save, I should go to the path computation, and I can see that tunnel has been created. And you can see it here. It's called Netflix tunnel, segment routing, and it has been created. If I hover over that particular row, I can see the actual tunnel. So the tunnel is going from node 32, 31, 33, back to 35. Now that I did this, now I need to get Netflix traffic running inside this tunnel. So to do that, I do exactly like I did in option 1. I take Netflix traffic, I steer that Netflix traffic, and instead of a next hop, I will pick an LSP. That LSP is the one that was automatically created, and it's discovered through the OpenFlow protocol. So I will use Netflix tunnel in this case. So in this case, I do Netflix tunnel, I do continue, I verify. It says active means all these 5 Netflix routes have been redirected to the alternate peering links using the LSP that was created. I just show you 2 options to resolve congestion in the network by doing smart analysis of the traffic, means associating that traffic to what applications. And thank you for your attention.